Thank you for being here with us. I know that it is later on this Thursday. Also, it's in a different hotel, so I'm very happy that you're here. Also, thanks for the tunes earlier. Those were really set the mood. I'm in a great place. Cool. So I'll get us started. My name is Ajuna Kiruzi. I work at Datadog. I'm here with my colleague Dija, and we're going to talk to you about driving cost optimization at scale. So as we all know, running on the cloud can be expensive. The cost of running our workloads has always mattered, but probably today and these days more than ever. At Datadog and other places, we care a lot about trying to reduce our costs. For us as a SaaS corporation, we also want to try to make sure we're passing on those reductions in costs to our customers who rely on us. We really think about this a lot. Internally, we actually try to track different performance wins. We actually have a Slack channel where if you have a cool performance win that you had, people post on there and folks kind of really cheer them on. Recently, we published an article talking about different performance wins that have saved us about 17 million over the past year. It trends from about one that was like 80K on the low end to about 4 million on the high end. Definitely encourage you to check it out if you're curious about other ways that we've been trying to optimize our work. And I mentioned I work at Datadog. Some of you may have heard of it, but if you haven't, Datadog is an observability and security platform that allows folks to gain more insight into their programs. It's really helpful. I want to say this because it's helpful to understand why optimizing these costs are so important to us. We receive and analyze tens of trillions of events every day from over 29,000 customers. That means that we are running on a very, very large scale. This is tens of thousands of nodes across multiple clouds. Specifically talking about AWS because I'm here with you today, but it costs a lot of money to keep all of this running. And of course, I want to share the lessons that we learned minimizing some of those costs with you. Because we get so much information in from all the people that use our services, we are able to parse that info and kind of get them into different reports that we publish annually. One of these is a State of Cloud Cost report that we published earlier this year. In that, we had different key findings about how people are using their cloud spend across their products. One of the findings that we had was that across different instance types that folks were using, the ones based on the ARM processor use up to 60% less energy than similar EC2 instances, and often it provides better performance at a lower cost. Kind of going along with that, organizations are trending up and spending twice as much of their compute allocation on ARM than they did about a year ago, which kind of matches what we were thinking about. We've been talking about ARM for a little while. We were here at re:Invent 2 years ago. A colleague of mine was talking about the lessons we learned transitioning some of our services to ARM at the time. This was more of a pilot program, and that talk was more focused on the work that we did to get our clusters and Kubernetes instances ready to be ARM by default. It covered a little bit more technical details. We also have a couple KubeCon talks around the work that we've done there, one actually in 2022 and another one just a few weeks ago. I'll include links to those at the end. This talk is actually going to be a little bit more about the program around what we did to get our large organization to transition to ARM, because as you all may already know, it takes a lot of work to get all of these engineers on the same path. So publicly, Datadog cares a lot about this. Our CTO's did an interview talking about how Datadog has used AWS Graviton to deliver more value while keeping costs constant. And actually, a few months after our last talk, so around February 2023, he issued us a challenge. So at the time, our ARM implementation was around 14%, and he issued us a challenge that our goal was by the end of 2023 to have 100% of our AWS workloads migrated to ARM, and with any exceptions, documented and approved. Generally, he sends out an email to us about quarterly with large-scale programs we're trying to do that quarter. So this was one of them, but obviously year-long because it's going to take a lot of work. And so throughout that, I'm going to walk you through the timeline of what that looked like for us. Obviously at February, and this is just a quick preview of the milestones that we impacted during that journey. As with all large-scale programs, it just takes a couple months to get started. So I'm actually going to have the story start in May, and I'm going to have Deja kick us off.
Thank you. All right. Hi, everyone. My name is Deja Cruz, and I'm on the FinOps team here at Datadog. I was part of the ARM migration program team, and this team consisted of representatives from capacity management, technical program management, developer experience, and then FinOps. So our role in this process was to figure out how we wanted to track the migration and then to build out those tracking solutions. With over 2,000 employees in our engineering organization, it was crucial for us to have a centralized effort in order to make sure that we reached our goal of migrating 100% of our workloads by the end of the year. It was also super important for us to figure out how much money we could potentially save so that we could make sure that we were using our engineers' time wisely and that this whole effort would be worth everyone's time. So, in the beginning, we used ddSQL to pull a list of our EC2 instances and their respective metadata. ddSQL is a query language for Datadog data. Personally, one of my favorite features of our platform and something I use quite often in my work. And we took that EC2 information and paired it with a reference table of custom ARM migration mappings of probable instance types. And then we also included a percentage of savings. Here's a snippet of what that ddSQL query looked like. We just pulled cost information from our cloud cost management product, joined it with that reference table of custom ARM mappings with that savings expressed as a percent, returned anything with net positive savings. This gave us a super high-level overview that told us, yes, that's absolutely worth our time. We like the savings that we could potentially achieve, so we decided to push forward. That brings us to an early challenge that we had, which was, how do we calculate the savings at a granular level? So think by team, by service, take all of that detailed information and then visualize that and share that broadly with our engineering organization. I'm going to talk a little bit about the numbers. We'll use an example here of migrating workloads. Let's say you're running on an M5.2x and you want to migrate to an M6G.2x. We'll use US1 pricing. This is the formula, super simple. Plug in the numbers, simplify the numerator, and then that brings you to roughly a 20% savings. So pretty easy to do. We did this for each and every instance type. And then here's what that reference table looked like. Here's a little snippet of it. You'll notice that it's actually showing 18% for that example that I just went over. And that's because we baked in a little bit of conservatism because no one's ever mad at you for saving more money than you estimate. So we like to be a little bit conservative with our savings numbers when we're estimating for projects like this. Now, we also, at this time, made a custom metric. We started with a baseline Kubernetes CPU request metric, and then we enriched that with information from our service catalog, so that way we could have even more information about the services. Now, one of the great things about observability is tagging, of course, and being able to use those tags to enrich your metric data with additional information, so that way you can increase the value of that metric data. And so also at this time, we refined our savings methodology. So we took that initial baseline set of estimates with the percentages, and we borrowed a methodology that one of our platform teams was using for their own estimations, where they looked at a per core cost. This was a great idea that we borrowed and incorporated, so we expanded our data set to not only include the savings expressed as a percent, but the savings expressed as a static cost per core. This was great for a couple of reasons. First, it reduced the noise in our data set because sometimes when you're using percentages and those prices fluctuate, the data can get a little noisy. And then secondly, because the custom metric was looking at CPU requests, looking at a cost per core aligned very nicely. So here's an example of some of the mappings. You'll see we have the ARM family and then the x86 equivalent. These are list prices in the US East 1 region. And so we took this information and then applied discounts and conservatism on top of that to get to our final numbers, but I wanted to make sure that I shared something that was broadly useful. You could take this and plug and play with your own discounts and assumptions of other discounts that you might have. You'll notice there are some NAs in this table. So I want to talk about one example that we ran into, which was the M5N. At the time, there was no M6GN equivalent, and so we had a team that was using a significant number of M5Ns, and we didn't necessarily want those to be excluded from this migration. So we reached out to that team, and we discussed their migration plan with them, and it turns out they didn't need that extra networking capacity from the M5N, and so they said that they were more likely to move to either an M6G or a C6G, so we went ahead and mapped that to an M7G. This is because the M6G and the C6G were even cheaper on a per core basis. And this is yet another way that we baked just a little bit more conservatism into that data, knowing that we would achieve more than the estimated baseline 30% of savings, that we would get closer to like 35 or 40% savings when they actually executed this migration. And so you may have noticed in that previous slide, there was a final column called cost avoidance. During this migration, we were still developing new products, adding new features, and so we were spinning up net new services, and we wanted those to be included in our savings estimates as well. The thing about spinning up net new services is you aren't going to see that cost reduction in your bill, but you will avoid future costs. And so we had to think about how we wanted to calculate those numbers. So we'll use a similar example. Let's say that you're spinning up an M6G instead of an M5. And so the equation looks very simple, except you're going to divide by your Graviton instance instead of your x86 instance. So here are those numbers. Simplify. This gives you a 25% cost avoidance. Both types of calculations are super important. One of them you will see directly in the bill, that first set of calculations that we went over, because you have existing infrastructure that will then be migrated to a more cost-efficient infrastructure. This, you won't see your bill decrease, but you will avoid spending an extra 25% on that same set of infrastructure. So, one of our first lessons that we learned during this process was to iterate early and often.
Yeah, actually, it's one of our core principles at Datadog. Our CTO often reminds us to be more biased for action. Getting out of that like ideation phase into a more iteration phase is something that we think about a lot. So this came up and kind of matched our principles pretty well.
Exactly. And then, you know, sometimes your early ideas are good, but not great. And so it's important to ideate, share, and gather that feedback as quickly as possible and as early as possible. So that way, when you do launch a large-scale program, you can feel confident that what you're launching is your best foot forward and you've really gathered information from across the organization. I mentioned earlier how we refined our savings methodology, and that was something that came from iterating early and often, sharing our ideas with some of our staff engineers and some of our large platform teams to really figure out how we could take all the best ideas and use those when we launched this program in May. So that brings us to June. We've increased our adoption rate a little bit, but not as much as we would like. And so the program team sent out a communication. We used Slack, we used email, encouraging engineers to prioritize this migration as part of their Q3 OKRs. June is OKR planning season for us, and so this was a great time to really get those engineers engaged in the process. And to talk a little bit more about what that was like for our engineers, I'm going to hand it back to Ajuna, and she's going to give you a little more insight on that.
Thank you. So I want to put you into the shoes of our engineers, right? February came, you got that big email from our CTO, and you're like, oop, gotta do that. However, there's still other work that you're doing. So I'm going to introduce you to one of our teams. We're going to call it Astro. This particular team deals with large business critical workloads. They have a lot of work that they're currently doing, so doing a massive migration is going to be a little bit difficult. They manage multiple different services. At the same time, they're running on multiple different types of x86 machines. They also have other priorities, right? They're building new services. They're deprecating old ones. So it was kind of tricky to being on that team and kind of having to balance all of those, all of that work that's coming in. So a problem that the programs team ran into was how to keep track of these services, of this progress across all these different services. So they came up with a easy to follow series of steps to make sure that it's automated. This is kind of what it looked like. I'm actually going to step through this carefully with you in this next slide. So most of our code lives in GitHub. When they're on GitHub, they get built into multi-architectural images. So wanting to make sure that those multi-architectural images were available for all of our larger repositories that are used cross-organization, especially to making sure that they had both x86 and ARM images available. Then once those are available, we push that into our container registry and making sure that there is duplication across multiple different data centers. Then we would deploy to staging, stay there for a little while, making sure the compatibility is working correctly, testing works, and then we'll check and make sure that there is capacity in our cloud provider, and then we would deploy that to production. That's kind of the steps that were laid out. So for a team like Astro, what we would do is first we would have to fill out a JIRA card, everyone's favorite activity. It wasn't required, but it was strongly encouraged because it made it easier to keep track across multiple organizations in one place. And also we already were using JIRA for all of our other project management work. So it kind of lined up pretty well. So there was a template created, just copy, paste, change, and include additional information like who's the contact information, what is like your Slack channel, when is the anticipation completion date for the migration? What are the list of services being migrated, and many more. Like we mentioned, our engineering org is over 2,000 employees. Making sure that all of them are doing around the same thing is definitely quite helpful there. So for the program team's JIRA board kind of looked like this, where incoming cards would get triaged, sorted, and then they're either being planned or in progress, and sometimes they would end up getting blocked for a variety of reasons that I'll cover in a little bit. But hopefully they would all eventually move to in progress and then get done. So the more difficult part here is building these multi-architectural images. Our previous talks kind of go into more of the technical details of getting those ready. However, this is the part where was a lot of work for our teams. For a lot of them, if they were using repositories that were cross-company, when those repositories were already being ARM ready or sometimes ARM by default, all they had to do was go into their configuration files in YAML and just make a quick change so that they could use ARM or just have multi-architecture available. We had tons of documentation showing all of our major repositories and when they would be ARM ready if they weren't. Most of them were ARM ready by the beginning of the program, so it made it a little bit easier. And of course, some teams aren't just using our major repos, they have their own team managed repo on top of that. So there was some additional work that they would likely were having to do or actually did to become ready. So we had a team that was our language tools team that was working with our engineers if they had an issue, getting their images to be ARM ready, kind of working them through that. So after getting to that stage, pushing to container registry, then it would go to staging. So we would ask teams to definitely stay in that staging area for at least a week because you want to see if there's any issues. And a lot of our exceptions and blockers kind of popped up around here. So for our exceptions list, it's very similar to the JIRA workflow that I showed you earlier. Generally, when an exception popped up, you'd fill out all of the information, send it to the ARM migration team, and they would either approve or reject based on the information required. Often they would reach out and ask for more context as it was needed to better understand and make more of an informed decision.
Yeah, the nice thing about these exceptions that I want to add real quick is that because we asked engineering teams to give us detail and reasons and put these on our board, we were able to really understand what those blockers were. And In my career, I've had the experience of helping numerous teams do this exact same type of migration and similar migrations, and so I've kind of seen some of these like pitfalls and gotchas when you run into these different types of exception, these blockers. Oftentimes, it was really just a matter of selecting the right instance type for the shape of your workload. Sometimes we tend to kind of copy paste when we're deploying new things, and we don't always double check that we've selected the most optimal instance type from the long list of instance choices. And so we would sit down with these teams and say, what's really the blocker? And oftentimes it wasn't necessarily that it would increase the price, it was that we just needed to get them on the right instance type. So this is super important to make sure you comb through those exceptions and truly understand the root of what's happening there.
Yeah. So to give you a quick visual of what our exceptions were looking like, this is from an early dashboard that was built by the programs team to get some insight. So the biggest chunk was people who needed a special type of instance. So generally they would work with Disha's team and figure out which one that they actively needed. Another big chunk was ones that were going to be deprecated, which was an easy one. We're like, oh, okay, easy exception. We're gonna save all the money because eventually that's going to go down to 0. But there were a few other ones that definitely popped up. Degraded performance on ARM also took a fair amount of time because the team then had to work and debug what exactly was going on there. And there are just a couple smaller ones that are around like compatibility issues that generally they would work through over and kind of they would work through it and make sure that they kind of unblock themselves through that. But it was a very small percentage. The biggest chunk was deprecation and instance types. So going back to our steps, after going through all these processes, you've built your multi-architectural images, you've deployed to staging. Another part that pops around for a team like Astro was checking cloud provider capacity. So I mentioned earlier that Astro, we were running large business critical workloads, and at Datadog, our scale is tens of thousands of nodes. So each team could be running thousands of nodes. To put it into perspective, why kind of going through all of these steps to check capacity started to matter a lot more, because we want to make sure that on-demand capacity reservations are happening so that the appropriate number of that instance type was available. So we worked with AWS's on-demand capacity reservations team to make sure that that got figured out. Generally, it wasn't a huge blocker for folks, just to make sure that not all the teams who want M6Gs are all just trying to do it all at once. But yeah. After that, we deploy it to production, and then it's a time to celebrate, kind of mark that one done, move on to the next thing. Which brings us to our next lesson, which is reduction of friction, right? When building these cross-company cross-company products or projects, it can be kind of difficult for folks to get started, and also if it's any more difficult than that, the chances that they'll do it kind of decreases across all of the other expectations and priorities that they have. So very clear documentation, making sure that as teams go through it and encounter issues, kind of making sure that things are updated to make the next round of folks going through it a little bit easier. But also having some pilot teams at the beginning try it out and also work through it. Kind of we partnered with a few engineering teams to get early feedback, just reducing as much of that work as possible so that teams felt that it was very easy for them to do the project. Which brings us to July.
Thank you. All right, so now it's the middle of July. We're at 43% adoption. As a quick reminder, early June was about 23% adoption, so we're pretty happy with this progress, but obviously still have a ways to go. And so at this point, the program team decided to engage our leadership team to help really increase that velocity and drive that adoption toward our goal. So for this section, we'll follow Astro's VP, Rosie. Not only does she need to understand what's happening with Astro's migration and all of the services that that team owns, but she needs to be able to see the progress in aggregate for all of the teams that roll up to her so that she can have a real-time update about what's going on with each of these services and figure out where she can help. So one of our other challenges that we faced was how to get traction and velocity at scale. So a VP like Rosie really needs to see all of this information, and that's where the program team came in and created a solution that was geared more toward our executive and leadership folks. So that custom metric that we talked about that we used, we ended up building on that. So as a reminder, it's just our CPU request for our Kubernetes workloads. We dropped every parameter of the metric that wasn't relevant to this specific program in order to kind of reduce that cardinality, and then we enriched it with information from our service catalog, so that way we could get the team information associated with that service. We then pulled information from our HR information system, so that way we could tie teams to their engineering managers, to their directors, all the way up to the VP level, and get that info from the organizational reporting chain. We also pulled in information from Jira, so those cards that we asked very nicely for teams to fill out, we took all that metadata from those cards and added it as a set of parameters on this custom metric. We also did the same thing with our container registry, so that way we could have as much information as possible in this one metric. We then took that metric and created a dashboard. So this is a snippet of our engineering-focused dashboard. It answered questions like, how much could I save if I migrate? How much am I already saving? It looked at a few other parameters and common questions, but I really want to focus on some of the info right at the top. So we also included links to our Confluence page that the program team created, and then that had the how-to guides, the Jira template, FAQ pages, links to additional documentation, et cetera, along with a Slack channel where the program team was available to answer questions that came up and help teams troubleshoot in more real time. You'll also notice that there are 4 giant numbers across the top. These are the 4 KPIs that we use to manage to track the health and progress of this program. So I'm gonna run through these pretty quickly. The first one is just our ARM adoption rate. It's simply the percentage of those cores in the scope of this program that we're running on ARM. So as I mentioned, July, we were around mid 40%. That second number is our ARM readiness number. So that's the percentage of our cores that could run on ARM. And so a VP like Rosie could look at this and say, how can I help decrease that difference between those first 2 numbers? Because we know that we could be running 76% in this scenario, but we're only at about 45%. So what else needs to happen? How can I help support these teams? Do we need to reprioritize things, et cetera? The third one is pretty straightforward. It's just our exceptions, so the percent of cores in scope that were linked to an exception on that program board. And then the last one was our Jira coverage, which is simply the number of cores that had a card on our Jira board. Again, it wasn't required, so the number was not quite as high as we would have liked, but it still gave us a pretty good insight into a good chunk of our infrastructure. Now, this is a snippet of our more executive-focused dashboard. Someone in Rosie's role is going to be interested in some of the nitty-gritty details, but ultimately is going to want to see something that's a little bit more financial focused, a little more aggregated. And so our TPM created a secondary dashboard with this information. So in this example, she can see that Astro is saving a good amount of money already, about 20K a month. That's awesome. There's about 12K left. And of that 12K, about 8.5 is considered to be what we called the addressable scope. We also had some info about the exceptions. So I want to talk a little bit about the schema because it's really important to understand kind of what's going on in that dashboard. So again, Astro's got about 20K, a little more than 20K of savings every month, has about 12.5 remaining. So of what is remaining to be migrated, we broke that down into easy, medium, and hard in terms of lift in order to help with prioritization. So the easy category is really just that delta between those first 2 KPIs that we talked about. So what could run on ARM but isn't running on ARM today? Everything else is ready. So in theory, this should be an easy lift. And if it's not, then we need to update those Jira cards and really have those conversations with those teams to figure out what those blockers are. Maybe it's just a matter of allocating more sprint cycles toward this. The medium lift was more about not yet having an image that was ARM compatible, so it was only still being built as like that single architecture, and that's why we considered it a little bit more of a medium lift. It's something that we knew could be done, but maybe there's something else going on there, but still relatively straightforward as compared to the exceptions. Now, those first two numbers are what we consider that total addressable scope. So our executives, our leadership team, like Rosie, can look at the total addressable scope and really focus her efforts there when she's having conversations with her directors, with her EMs, things like that. So that way we could really reduce those numbers because we knew that the exceptions were gonna take a little bit longer to work through. So we're now at September. We've jumped a little bit to the end of the third quarter. The program team is reviewing the progress. I'm gonna zoom out a little bit and talk a little bit about a couple of the widgets that the program team would sort of look at in order to figure out what was going on. I do wanna note that even though it is the end of the third quarter and we're roughly halfway through this process, at this point, we also did a regression analysis on our progress thus far to figure out the impact of this program relative to where we were trending before we launched the program in May. And we found a significant uptick in adoption that we could directly attribute to the program because of all of the ways that we were tracking this. And so we were pretty happy with the amount of money that we were saving and some of the cultural changes that had happened as a result. We still wanted to push ahead though. So here's one of the widgets that we would look at. Again, we use that custom metric that pulled in all of those different sources of info. So we would look at not only the service name, but also like some of that JIRA info, figure out how many cores were still running on x86, how many were running on ARM, and then a slightly different view. We also would have widgets that would have the estimated savings tacked on at the end because that was also, important for prioritization. That brings us to another valuable lesson that we learned, which is to make as much of this work visible as possible. You know, we really leveraged our platform with that custom metric and pulling in different sources of data from our HR information system, from JIRA, from our container registry, things like that, and putting it all in one place. Also having teams not only file a ticket on that JIRA board, but also let us know, you know, what's your ETA? That's fine if it changes because we would rather have the accurate information in order to make informed decisions. We also had that exceptions board that we talked about where we would get detailed reasons and we would try to categorize that. All of these things together made for a lower friction, a more successful program. And so it also would enable us to figure out how we could continue to help our teams, how our executives could continue to help our teams really drive toward this goal. I'm gonna do a quick little recap just to, because this is a lot that we threw at you guys. So February is when our CTO was like, all right, I want all of you to migrate 100% of your workloads on ARM by the end of the year. We had just come off of the reInvent talk that we did, and then we needed to gather the program team together. So we spent March and April looking around and kind of figuring out, okay, who's going to be involved, what resources do we need, building out those Confluence pages, an early version of some of our dashboards and that custom metric, and then also the savings estimates, of course, because we want to make sure that this is going to be a worthwhile effort. And then by June, you know, we had some good progress, but we were about a fourth of the way through. And so that's when we asked those teams to really please prioritize this. You're doing your OKR planning. This is a great time to really allocate the time and energy toward doing something like this. In July, we engaged our leadership teams to really help drive that velocity. And then in September, we, being about 3/4 of the way through the calendar year, that's when we did kind of a look back to see, all right, where are we going? How, you know, how's our progress looking? Has this program been impactful? And so that puts us at December, in Q4, we continued to see adoption. We felt like we had all of the pieces in place, and so now it's just a matter of iterating through those processes, right? Through those steps that Ajuna went over, continuing to engage those leadership teams, and really just doing the work. So by the end of December, we were at about 61% adoption. We still consider this program to be successful because when you add in the exceptions, that puts us at about 82%. Obviously not 100%, but a pretty good effort. And we had this long tail that we were continuing to track. We had all the pieces in place, and so we knew that we would eventually get there. Plus, we had done that regression analysis to confirm that this program was indeed impactful, and we did increase our velocity. So this was a worthwhile endeavor. We decided to close out the large company-wide program, and instead, my team, the FinOps team, started to just track this program as still as a program, but not as a company-wide program, and continue to really drive that adoption. So the other cool thing about dogfooding our own stuff is that teams could track their progress in real time, right? So this is a real example of a real service, real numbers and everything, and all this team did was change what architecture they were running on. So you can see here, there's a mix of x86 and ARM. They obviously didn't fully go to ARM. We didn't require teams to fully go if for some reason they still needed to run on a mix or if there were capacity, things like that. So the nice thing though is that even with this mix of x86 and ARM, this team saw about a 13% reduction in the average daily cost, so that's still pretty good. One more example, again, this is a real service, real numbers. This team obviously adopted a lot more ARM in their infrastructure mix, and so the great thing about this is that this team saw a 29% reduction in the average daily cost. So really benefiting from those ARM machines being more performant, and then, just seeing like some pretty great results. At almost a 30% cost reduction in your average daily cost is not bad. So, what's next? What's next for Datadog, for this program? I'm gonna hand this back over to Ajuna to kind of wrap us up and take us through what we're gonna work on next.
Yeah, so what's next? That long tail, it's going down. We're gonna make sure to kind of clear it out as much as we can. A big chunk of that is obviously unblocking the exceptions that are happening. Obviously, teams had to file exceptions, as some of that is due to deprecation. So there's a high level of effort to make sure that that deprecation actually happened so that the costs have been enabled there. So we do have charts that the FinOps team created that they're able to keep track, and we're hoping to continue watching this number get closer and closer to zero. We're trying to get as much information as we can and make sure that we're tracking all the different additional types of savings that happened. So going back to that cloud cost report I talked about earlier, we found out that a lot of organizations, Datadog included, are still using previous generations of EC2 instances. There's a variety of reasons why, but another thing that's next for us is to continue improving the instance types that we are using. We did get some folks on ARM. They might be using an earlier version of Graviton than like Graviton 4. They might be using 2 or 3. So the benefit of this program is that we've gotten these folks in a space where they are ready to continuously make improvements, right? It is not just the cost reductions that we've had for right now, but unlocking that to make it easier to continue to make this progress and upgrading to better and cheaper services. So, kind of close everything out. For our lessons that we learned here, obviously, the first one, our core principle, iterating early and often, making sure we get a ton of people working on it. They all have great ideas, and even though we had really cool out-of-the-box solutions that we're excited to use, like our cloud cost management product, working with folks and getting some of that insight, like how much is it per core, adding in that personnel data, all were things that made that product even better, and we are using them internally outside of this project itself. So definitely getting a lot more insights there. with such a large-scale program, making sure that it's as easy as possible for our engineers to do during it so that it's just not more work for them. They have a lot of priorities, still releasing new services, so making sure that this wasn't something that like dragged us down as we were trying to like continue moving forward and releasing cool new things. And of course, keeping track of everything. This is a long-scale project having happened over the entirety of 2023, so making sure that our engineers felt supported and seeing the progress that's happening and it being company-wide definitely made an impact for them to see that this is worth it. We're all kind of working towards the same steps. And then also maybe there was a little healthy competition happening between some of the teams and the VPs to see who got closer to 90, you know? Not in a bad way, but just like being like, we're all doing this together, making sure that this work is very, very visible. So I mentioned a few resources, including some talks that we've done in the past. I'll leave this slide up for a second for anyone who is curious. The State of Cloud Cost report is at the top. The second thing is an article that we actually published on Monday, so fresh, hot off the presses, talking a little bit more about the work that we did migrating our Kubernetes fleet on AWS to ARM. So it'll cover some of the things that we talked about today, but also some of the technical details of getting our Kubernetes fleet ARM ready, and then the 3 talks that I mentioned earlier. Here's a screenshot of that article. I mostly wanted to show you this cool header that I'm very excited about. Notice that it has little arms and the little, like, I don't know, I really like it, I apologize. Okay, moving forward. I'm really excited for you all to have joined us today. If you want to work on cool things like this, we are hiring, would love to talk to you about it. This QR code goes to our careers page. Check it out. We also have a gorgeous booth. You don't have to write our slide to get there, but you know, try it. It's in the Venetian. Go check it out and chat with folks. We're not doing too much recruiting at the booth, but if you want a demo and find out more about how Datadog works, definitely go and ask the experts that are over there. So thank you for your time.